Okay, let's start solving one-step equations when we have to multiply and divide. So our three things we're going to be able to do, we want to be able to model the one-step solutions with equations. We also want to be able to solve them and show the process, and then verifying at the end. So in terms of modeling, this is what it would look like. So for 4x equals to 16, I know that there's 4 cups, and then because they all share x, they must be the same cups. There's the same amount inside each one. And then for 16, there's 16 counters. So what we're trying to decide is how many counters would go into each cup. So for this, we're just going to divide it evenly. And I can see if I have 4 cups, I could split this into 1, 2, 3, 4. And so each cup would actually have 4 counters. So the solution to this, one of those x's, one of those cups, is equal to 4 counters. On this side over here, x divided by 3 means if one whole algebra tile, so for example, one long green tile is x, I only have it divided by 3. So this whole green tile, I only have 1 out of 3 parts. So 1/3 of this is worth 6 of these red tiles. Keep in mind, in integer chips, red ones are positive and then white ones are negative. So if I'm looking for one whole green algebra tile, what I need to do is make this bigger. So I need to find out, if I think about it, if I add one more of these green pieces, that's equal to 6 more red. 1, 2, 3, 4, 5, 6. I'm just going to fill them in so that they represent positives as well. So same as that first one. And then I'm going to fill in that last segment, which is also going to be worth the exact same amount. So there would be 1, 2, 3, 4, 5, 6. And once again, I'm going to fill them in. So now visually I can see 1x, so one long green tile, is equal to 6, 12, 18. So in this one over here, x is equal to 18. All right, give these two a try on your own. You can pause the video and give it a try. And then once you're done, your solution, one of these x's should be equal to 5. And then for this other side, one of these x's would end up being equal to 30. So hopefully you got to the same spot. Let's try these. So if we're solving by inspection, it means we're not really too fussed about how we show our work. We're just kind of doing mental math. So if you see 5g equals to 15, there's no operation that you can see, but these two are touching. So when a letter and a number are touching, what we actually mean is they're multiplying. We just no longer really want to use this multiplication sign anymore because that would look like an x. So this is 5 times g equals to 15. So thinking back to our algebra cups and counters and our tiles, this would be the same thing as having 1, 2, 3, 4, 5 cups equal to 15 of these counters. And so each of these cups would be worth a G. They're all exactly the same letter. So I have 5 of these cups. Each one is a G. And so if I want to figure out what 1 G is worth, I'm just going to have to divide my total of 15 into 5 sections. So 1, 2, 3, 4, 5. And so this way it looks like each G is equal to 3. The other one, if I take a look at it, x divided by 4. So remember, this whole thing is 1x. And so I'm just going to chop it into 4 pieces. I really only have 1 out of these 4 pieces. And that would equal to 5 positive. So 1, 2, 3, 4, 5. And so if I want to fill out this whole x, then I can visually see I would need to do this single piece times 4. So I really need to multiply this side by 4. So I'm going to multiply this other side by 4, and that would mean 1 whole x is equal to 20. All right, so give these two a try on your own. So pause the video, give this one a try. 3, 2, 1, and then here's your answer. So for the left side, k should be equal to 9, and on the right side, m would be equal to 14. Okay, let's take a look at modeling this a little bit more exact now. So what we want to do is, once again, be careful. If you're multiplying, you're not going to write the x because that looks like a letter x. So to show multiplication, we're just going to be touching, right? So two things that are touching means multiplication. We're also not really going to use this divide sign that much in algebra as well. So if you want to show divide, it's going to look like fractions. So having this line, so for example, 3 over 4, it's the same thing as 3 divided by 4, right? So that top number divided by bottom number. Okay, so suppose a track runner could run at a constant speed of 9 meters per second. This distance traveled is modeled by the formula d equals to 9t, where d represents the distance and t represents the time. How long would it take for the runner to run 900 meters? Verify your answers too. So first of all, I'm just going to rewrite out the equation. 900 equals to 9t. Don't forget to define your variable. What does that letter mean in a word problem? So let t be time in seconds. So now to solve it, if I think about it, once again, your equal sign is like a scale. So anything I do to the left, I have to do to the right. I can't cross over between that equal sign. So if you just imagine this barrier, it doesn't really exist there, but you can't cross between the two sides. So to show your work for each side, what you're going to do is do the opposite operation, just like we did with adding and subtracting. So I'm going to highlight my variable. I need to get this t all by itself. Right now that t is touching a 9, and that means it must be multiplying. So the opposite of multiplying is to divide. So I'm going to go 9 divided by 9. 9 divided by 9 gives me 1. So now instead of 9 cups, I have 1 cup, and I can just represent that with a t. So it crosses out and it's gone. But anything I do to one side, I have to do to the other side. So I'm going to do the same thing and divide by 9 here. I'm going to line up my equal sign and then figure out what I have left. So on the left side over here, I have 900 divided by 9, and that's 100. On the right side, I have only a t. So at this point, I've actually solved it. 100 equals to t, which means t is equal to 100. It doesn't really matter that my letters on the right-hand side, that's totally fine. So how long would it take to run 900 meters? It would take the runner 100 seconds to run 900 meters. Or if you wanted to be fancy and turn it into minutes, or 1 minute and 40 seconds. So last thing, we need to verify our answer. So what I'm going to do is just plug it back in. So if you think back to the original formula, that was 900 equals to 9t. Now I'm just going to plug it in. So on the side that has a letter, I'm going to put in my 100. So there's kind of an issue because right now it looks like 9,100 instead of 9 times 100. So don't forget to always put brackets. This tells me that now the 9 is touching a 100. It's not 9,100. And then 9 times 100 is 900. So check. 900 equals to 900. Left side equals to right side. It must be okay. All right, so on a question like this, we have Sylvie and Marie earning money to deliver groceries. And so last weekend, Marie earned $29. This was 1/3 of the amount that Sylvie earned. How much money did Sylvie earn? So first thing we want to do is define our variable. Let G be Sylvie's money. And then in order to solve it, we're going to go G over 3 equals to 29. And I'm just going to highlight that G over here. And so for this one over here, because G is dividing by 3, the opposite is to multiply by 3. So multiplying by 3 and dividing by 3 means you really have no change. So now you're back to just G. 29 times 3 is 87. And so my answer, Sylvie earned $87. And verifying my answer, I'm just going to plug it back in.
So if I go 87 divided by 3 equals to 29, let's just give this a try. So 87 divided by 3, 3 goes into 8 2 times, and that's a leftover of 2, and 3 will go into 27 9 times. So that seems to check out. 29 equals to 29. So that's good. All right, hopefully that gave you a good set into multiplying and dividing fractions. Good luck with your work.